Find a seat, because we now have another keynote, one that I've been looking forward to. I actually asked Frances when we met for the first time, and she started to talk about the NATO Conference on Software Engineering in 1968. But I don't think it was then, Frances, I'll be frank. But for those of you that know IEEE software, I think many of you, most of you, if not every one of you knows that magazine. Frances was editor-in-chief for IEEE software during
the 80s.
The 80s. Well, did we get to know each other then? I think it was later. But in any case, so she's been very active in the IEEE software community. She's worked for Siemens, I think most of your professional life, if I'm not mistaken. Frances set up a complete architecture training program at Siemens that thousands of architects, I think, took themselves through. And then spent the last years of her professional career working for Siemens Healthineers, which is the healthcare unit of Siemens, to work on X-ray machines, ultrasound machines, and other things, and to work on software excellence. She recently retired, which means that she can now say anything that she wants without being checked by people from Siemens, although maybe there are still a few things that you're not able to talk about. But what we asked her to reflect on is basically the past, the present, and the future of software engineering, also as an opening for the fishbowl that we want to have after the keynote, before we start to close up. So with that, I would like to invite you to join me in welcoming Frances on stage. And I'm really looking forward to a wonderful keynote.
Yeah, thanks so much. So I can skip already my first slide. So as mentioned, this.
You may have to start pressing buttons.
Yeah. Okay, so I've been doing software basically all of my life, professionally all of my adult life, and professionally at Siemens AG and Siemens Healthineers, as Jan mentioned. I'm recently retired, so you are my first post-retirement pilots. So I hope you're friendly stakeholders. So it's not going to be a very technical presentation, but I hope at least partly also an entertaining one. So we're going to start going way back in time. Thank you, Jan. Going way back in time, and my personal connection is actually not back in '68, as Jan indicated, but more 50 years past. So there's two definitions of where the term software engineering came from. They're sort of competing definitions. And they were celebrated in 2018 in two different ways, and you can see that in the two pictures here. The ICSE, the main international academic and research conference on software engineering in the world, was here in Gothenburg in 2018. And Ivica, as many of you, I believe, know and respect and loved, he was the general chair, the main responsible person. He brought this conference to Gothenburg. So you can be really proud of that. And that was a fantastic conference. It had two keynote speakers, one of them who was from the University of Newcastle, Brian Randall. He was one of the proceedings editors of the 1968 NATO conference proceedings on software engineering. And also Margaret Hamilton, and I will be sharing a little bit why Margaret Hamilton is important. And she was also a keynote speaker, I think with 80 years old, at this ICSE in Gothenburg. And Ivica got her to come here and give the keynote, and it was really awesome. So in the NATO conference, was back in '68. It was actually organized in Germany by Professor Bauer of the Technical University in Munich, in Garmisch, Germany. And there was quite also some international participants, so from the US, also Edsger Dijkstra, a Dutch, very well-known Dutch computer scientist, Peter Nauer from Denmark, Alan Perlis from the US, and many research institutions and also companies. Siemens was there, IBM, Bell Labs, AEG Telefunken, if you still remember them, and many others. Software engineering was chosen explicitly, and these are quotes really from the proceedings. It was chosen explicitly to be a provocative title, describing the requirements describing this as a requirement rather than a reality. And I think it's maybe interesting to know that the term software crisis also was coined in this very same proceedings. So software engineering, software crisis, pair programming in the proceedings, right? And Helena mentioned the topic of feedback in your presentation before lunch. And I wanted to also explicitly mention that in this proceedings, the topic of the need for feedback was stressed multiple times in these proceedings. And I cite here at the bottom, you'll see a couple of times in the presentation, I have these little brains down here. These are sort of like footnotes, maybe useful information. I'm trying to include a little bit of information that you maybe don't know already. There was a classic paper in 1970 that's always quoted by the waterfall folks, right? And even in that paper, go and look at it. You can find it in the internet. The PDF, it shows that it isn't just a waterfall. It has feedback cycles. So even then, they knew waterfall was not right. So the only people that are requesting waterfall do not understand software engineering. I will try to include a couple of jokes. I try to take Jan's example. So first a quote, not a joke, by Edsger Dijkstra. If debugging is the process of removing software bugs, then programming must be the process of putting them in. Okay, now speaking of bugs, why do programmers prefer working in the dark mode, right? So when they're editing in the dev environment, they prefer the dark mode because the light attracts bugs. Okay, but as long as we get some laughs, I'll get more laughs in the keynote than in the panel. We'll see, have a competition. Okay, one more bug story. So software engineering, software crisis were coined in 1968. Software bugs actually were first documented in 1947. So way prior even to software engineering, we had the first software bugs. And this happened in 1947 in a relay-based computer at Harvard and was discovered by the Rear Admiral Grace Hopper of the US Navy. And it was actually a physical moth who flew in between the relays and got burnt and got stuck there and caused the machine to malfunction. And Grace Hopper was a fantastic promoter of software topics, a very highly respected woman. And she is also responsible, you may not know, for the quote, "It's easier to ask for forgiveness than to get permission." That quote stems from Grace Hopper. Oh, sorry, one more thing back. This is a picture of from the conference hotel in Garmisch. It still exists today. And you can see it's Douglas McElroy of Bell Labs giving a presentation on components. And Doug McElroy is actually was very focused on components. You may know the Unix pipelines. So he was instrumental in defining the Unix pipelines and things like diff and graph and plot. And so he would explicitly say, graph is a tool used for defining the graph, and plot is a tool for printing the graph. And those don't need to be together in one monolith. You put them together in a pipe, right? Fantastic ideas, right? And this, by the way, is, I think, Dijkstra looking at him from the right, the guy with the white shirt and glasses looking intently at Douglas McElroy from Bell Labs. Okay, so the Swedes were not there in this NATO conference because Sweden was not at that time in the NATO, right? So there were others there. There was the Dutch, Dijkstra, Peter Nauer from Denmark, Trygve Renskog from Norway was there, but Sweden was not. But they were very active in the community, and there was a very active community in Scandinavia on software topics. Now, some people argue that actually the Swedish were the first programmers, because they were very active with these things like flute clocks. And these are very much like bits. It's like this music box, right, that sometimes children have today. It was really the first case of recorded music that you could play at home. You didn't have to have the musicians come to your parlor. You could play basically the pre-recorded music on this. And actually, Sweden was had for a while one of the fastest computers in the world. It was the first electronic computer that used vacuum tubes instead of relays, because the relays, of course, attract the bugs, the moths. But they had vacuum tubes, and this was used already back in the 50s and 60s with some really cool topics like creating an animation of a car. It was one of the first computer animations, and Saab used this for making calculations for their aircraft. And this was led by a guy called Conrad Palm. And they named, I'm not sure if I'm pronouncing it right, but supposedly they named this system the BESC because it sounds like a particular distilled alcohol with herbs from the Skåne region. BESC. Is it known? Yeah. Okay. And they only chose BESC because their first attempt to have a pun to name their topic, they wanted to call it a little bit like the ENIAC computer in the US and call it cognac because of Conrad Palm. Okay, and now the second story on 1968, and the rest of the slides will go much faster. I'm not going to take you through the whole history of software engineering, but this is a really, really important topic because actually I believe this actually, in my view, actually predates the NATO conference. So there was a lady called Margaret Hamilton, and she was a mathematician, and she worked on the SAGE project at MIT, Lincoln Lab, and this was closely related also to the NASA topics. And she became the lead developer for the Apollo flight software. She was actually a system engineer, but then she coined the term system engineering to distinguish this from that it was sort of like system engineering, but different and part of the overall system engineering process. And one of her areas of expertise was the error detection and recovery topics. And you can read the details here. But the point was that she was very aware of this error detection. That was actually also the topic of her keynote at the ICSI in Gothenburg. And so they had these very small computers in those days, and it could only handle 7 processes running at one time. And there was a way that she foresaw the possibility that maybe there would be more than these 7 processes running, and to be able to handle that in a resilient way. And that saved the day. Buzz Aldrin was 3 minutes before the lunar module eventually landed on the moon, 3 minutes before it set off an alarm because Buzz Aldrin pushed that button an 8th time to find out the altitude. That 8th time caused the alarm to go off, caused the system to prioritize, to throw away all the other information like telling Buzz Aldrin the altitude, and to prioritize on landing the lunar module on the moon. This was coordinated with home base in the NASA headquarters, and there was a person there who, of course, knew of this error recovery system. And when he got the question, do we do a go or no go for this flight, minutes before landing, he said go, and they landed successfully. And the rest is history. Landed on the moon. You can see Tranquility Base. This is a picture of Buzz Aldrin from the back, taken by Neil Armstrong. You can see here Margaret Hamilton in the 2 black and white photos back in the day, and a picture of her at the time of the ICSI conference in 2018. So, and the rest is history, or I guess we could say herstory. Okay, in what way is software different? So Jan mentioned in his opening this morning the different waves, but I think it's also important to, in addition to these waves from mechanics to electronics and internet and so on, in addition to those waves, to consider that software has some fundamental differences to physical systems. Jan likes to call this bits versus atoms, for example, right? And it's important to be aware of these to make sure that we apply approaches to software engineering that are really appropriate in the software world. And I won't go through all of the details here, but I think the 4th one from the bottom about the diseconomies of scale, I think is a particularly important one. Is also characterized by the picture on the right of the milk cartons, that people do not understand software, think milk is cheaper, software is cheaper in these bigger cartons. but it's actually in the software area, there's really a fundamental advantage to having things in smaller chunks. And I'm preaching to the choir here, right? You're at the software center, you're members of the software center set of companies, and you know that's why we're going up this stairway to heaven and all the different models you're calling it now, to have these smaller, faster, now more increasingly AI-powered pieces to develop our systems. And another quote also by Donald Reinertsen, who's very well known in the product management space, making it clear also from his perspective, he's a very well known also for queuing theory and is scientifically well grounded, that doing software development or product development as big chunks, as just big monoliths, is not only a little bit wrong, it's wrong to its very core. So there's a number of trends that I wanted to mention, right? It's all of these things are going on simultaneously. It's not only a technology topic, but I think is often cited here also in the central themes of the Software Center from the beginning, right? The focus on business and also increasingly the social aspects and the culture aspects. And software is becoming the driver in all of these areas, many that you are involved in, right? With transportation and aviation, telecom, medical, energy, and so on. And speaking of cars, did you hear the joke about the crash involving autonomous cars? They did find the reason for the crash. They had installed the wrong drivers. Okay, so we're shifting to much more functionality being realized by the software, as well as products that would not be feasible without software. And there's really actions going on these days, really taking out lots of the cables, for example, also from cars, or I think maybe also from trains, taking cables out to make the product lighter and have other replacing that functionality that was previously done with the cables by software, for example. So there's many trends in this direction, and these all lead to the fact of making, things like architecture agile, or maybe we call it radical now, but basically the agile plus, and having people involved that are interested in learning what are the latest activities. That's why we're here together in the Software Center, to focus on the software culture and this learning oriented. We don't want to develop things the way we did long ago. If you take an honest look at it, we haven't really made that much progress from 68 to now, right? We really should have been making more progress. There's two more footnotes here with the brains. One, I want to warn you a little bit about the so-called Standish reports. At least in the early days of their approach, I'm not sure exactly if that's still currently the case with the Standish reports. But if you look at it on the internet, you can see some very well-known persons criticizing the Standish report for that they're not based on sound scientific approaches, and they have a big lack of transparencies, right? And so be careful what you read as motivation, because you hear these Standish reports and there's so many failed software projects, so you have to do X. There's so many failed software projects, so you have to do Y. It's in so many cases you see in the literature and the publications, it's given as the big motivation, and it's just not based on fact. There is lots of facts that do actually show failed software projects, but I would not rely or want to put my name on using the Standish report as a motivation for that. Also, there's many misinterpretations, ignorant interpretations of things like Agile or even CMMI. CMMI gets a bad rap, but it really had some very good ideas. It was just misused. And a lot of the criticism people have of Agile is also criticism of the people that are out there saying you must use a particular framework or you must buy these certifications and so on, right? There's a lot of people misusing the terms, but it doesn't necessarily mean that they were bad inherently. So I think that there's actually a lot of useful things in them. But you have to, of course, use your own interpretation and understanding, and don't just buy what you see. So moving on to artificial intelligence, and I'm sort of lumping generative AI and machine learning all into this. So artificial intelligence, just in general, is an interesting phrase. So coming up a joke here. Did you know that the scientists predict human-level artificial intelligence by 2030? Maybe sooner if the bar keeps dropping. Okay, so while I do believe that there are currently significant benefits through AI, I really do believe that, I think that we are not, as a community, sufficiently aware of the potential associated challenges of the topic. And I think also that we are maybe overly optimistic of the potential to be achieved within time X. And the next slide I will be showing some example of what I call here 2A, about what areas, for example, it's more useful in than others. But I'd like to also point out this topic to be especially clear. I don't think we talk so much in the Software Center about the ownership, responsibility, the legal aspects behind this. And I think that it maybe makes sense. Consider if you're doing code generation, say with GitHub Copilot or some other tool, it's being trained on what? It's being trained on GitHub, right? Even Margaret Hamilton's code is out there on GitHub. That's all potentially. I don't know. For example, I don't think it's known exactly what GitHub Copilot is being trained on, but it's being trained on, say, all or most of GitHub. Now, is that all the best high-quality secure software? I don't know. I would think it would maybe make sense to, have it on a subset of more high-quality software, or have some way of determining that. Maybe it makes more sense to apply it on your own software bases that you have some view on it being more high quality. So I have some reservations about the training data that goes in there. And there's a lot of open source projects that are in there, and I'm certainly not questioning the quality of the open source. I think there's a lot of fantastic open source software out there, but it's sort of misusing the open source community, because it's taking these projects and is sometimes passing them on as output from GitHub Copilot, right? It's sometimes passing on things that maybe should be attributed to the original author, and is not always doing that correctly. And what you get out as the code, you have to, of course, take responsibility of the code that comes out of the system, right? And so in many cases, it's important to make sure that the human is involved in this, right? If it's totally 100% generated, then it's challenging from the ownership and responsibility perspective. These are all topics just related to the code. For all kinds of other use, like using it for test cases or for requirements and so on, there's a lot of things that don't get into this whole issue. So be aware of the hype, and the benefits don't apply equally to all kinds of projects and tasks. And I do think that things like design and architecture and having those being done by very experienced persons will still, for a long time, still be very important. I put a footnote here at the bottom about an interesting report I read about the McKinsey State of the AI in 2025 report that analyzes a bit also the scientific approach that they used in providing some of the data that's shown here. And I think that might also be of interest to you. So now I'll show the topic that I was referring to from the Stanford University person, Egor Denislov Blanche. And I summarize the insights on the right, that, of course, it does make sense to use AI, but use it wisely, that it is, in many cases, it's applied to, the productivity is estimated based on smaller examples. And if you use it for more complex examples, and what are we doing in the software center if it's not complex systems, right? It doesn't scale as well from small systems to very large complex code bases. So need to have it be more careful, right? Also, greenfield projects will be easier for AI to do things with than complex legacy systems, right? And so be aware of that. In some cases, because of all of the adjustments you need to make to the code afterwards, you might potentially even have negative productivity, even if you even measure productivity by, say, lines of code or time. Then you may have to do so much adjustments to the code to fix bugs or to integrate it with the rest of your systems that you might be less productive than before. So these are all things just to be aware of, because I just have the feeling that they're not sufficiently looked at. But the overall big picture is, in my view, also positive. I do think it makes sense to have Gen AI and to artificial intelligence, but be aware of these issues so you don't fall into those traps. So it will bring positive, significant benefits. Like as Jan said this morning, every wave creates more opportunities than it destroys. I agree with that 100%, and we'll get better at doing this. Maybe we need to structure our systems into smaller chunks so that we can apply Gen AI to those smaller chunks more effectively, for example, right? That would be a useful approach, and make it so that, like back in the day with the component example that I mentioned with the graph and plot algorithm, have those systems be set up so they can function independently, right? And then that might also make things easier even for compliance topics. So coming to a close, I think we're going to have lots more of what we're already doing in the software center, or what you're doing in the software center, more continuous delivery and deployment, more data-driven topics. There's going to be lots more focus on cybersecurity and also other regulatory topics. So the Cyber Resilience Act, I think, was mentioned a couple of times. We're going to have more and more interconnected systems, more need for scalability. We're going to be moving the edge of what all we can, where we can all apply software to new kinds of products and new businesses. And we need to focus on efficient and effective ways to meet the many regulatory requirements. I was really happy to see all of the work that the Software Center is doing in that direction, and will hopefully be working on in the future. And pay attention to the impact on society. Things like the social media networks causing communities to be divided amongst each other, right? And things like that. And the sustainability, where's all the energy coming from to do all these AI topics and training. We need to also make sure that we sufficiently take care of the impact on society. And so I view these topics at the bottom as the sort of the future directions. I think there's going to be much more in artificial intelligence, in all the various aspects of it. I think personalization, I think we will have the opportunity to make things much, much more personalized with the use of software. Sustainability, I think, is a really important topic for us to continue to address in the development, and making sure that the products that we create are also sustainable. There's a lot of ethical considerations, all the privacy, accessibility, can people really use the systems the way we've developed? Addictive design. I mean, there's really people that are focused also on this research area of really considering, like we have some system doing video games, to not have that lead to addiction to these topics, right? These are all sort of more society relevant topics. So the algorithm bias that one might have, right? And the transparency that we need. Quantum computing, I think, came up earlier also. Quantum computing will let us address new topics that we haven't been able, new areas, the next moon, right, so to speak, in software engineering terms. I think also digital data sovereignty topics. technological solutions to maybe have the EU-specific cloud providers and all the legal and political aspects associated with that, I think is an important topic. And I think overall, sort of like the picture showed up at the top, the mind versus machine topic, finding that right balance between, I guess you called it autonomy and empowerment, right? That right mix. How much is the mind controlling that? The software engineers aren't going to be maybe writing that code, but they're going to be controlling how it's written, checking it, and making sure it makes sense, that it's safe, secure, and so on, right? And to be able to do that. Okay, one last joke. I've got a few more minutes. One last joke, or almost two. You know the kind of nerdy bar joke pattern? So XXX goes into a bar. So like, for example, a proton goes into a bar and orders a beer, and the bartender asks, "Are you sure?" And the proton says, "I'm positive." So that was just the example of the joke. The actual joke is a machine learning algorithm goes into a bar. And the bartender asks, "What would it like to drink?" And the algorithm replied, "What is everybody else having?" And with that, I will close. Thank you very much for your attention. I'm open for questions.
With that, you're actually early. That's well done. We have time for a few questions. I'm not sure if the microphone is available. It is. Who has a question to this 1968 software engineering? Sorry. Any questions? Because I have questions if you don't have them. Yes, Barbara.
Sorry, Barbara.
Just a second, you're getting a microphone.
So thank you for the talk. Nice remembering 1968. I always do in my course. And I just want to add that from that conference also dependability was born, because Brian Randall went home and started with fault tolerance, and Dijkstra started with fault removal. So they go hand in hand.
Mm-hmm. Yeah, terrific. Yeah, thanks, Barbara, for that comment.
Yeah, and interestingly, there was what is it, Edgar Dijkstra and who's the guy who's now in Ireland, the Canadian. They were at conferences. They were both the senior researchers in the field, and they made a practice of who could insult the young, insecure presenter on the stage the worst. It was Dave Parnas and Edgar Dijkstra. Yes, yeah, I think you were at the receiving end of that. Is that? Yes. No, it was not pleasant.
Yeah, but he was very instrumental in the information hiding topic, right? Which has really had a huge impact.
So, Francis, what will software engineering look like 10 years from now?
Well, as I sort of indicated, I think persons will subdivide the systems, and then we will have software that orchestrates that. And that may be these agents or whatever. Right? And each of those parts, we need to try to strive that each of those parts can work more independently from another. And so that there will be AI in those parts and in the orchestration, but there's still the people in control.
Very good. Thank you. Any other questions? Because we're going to switch to the fishbowl now, if that's okay with you. Yeah? With that, let's give Francis one more round of applause. And the presents are coming because she did run. We have a small token of our appreciation here.
Thank you very much.
Yeah? You know, you may use that to keep yourself warm now that you don't have the blanket of Siemens anymore. Yeah, thank you very much for coming out. Wonderful.